Okay, this video is for our year 9s. This is your chemistry introductory module, and the first lesson is going to be states of matter. You have already been sent all the information in terms of how to prepare for this, so I am going to do a quick overview of states of matter. If you visit BBC Bitesize and visit the combined science page and use Edexcel, that's the examination board you are doing, and then you can follow this or read the notes on this. So states of matter, we're looking at 3 states: solid, gas, solids, and liquid. So arrangement of particles in gas, they are random and far apart. Their movement, they are moving in all directions. Excuse me. Other important things to note for gas: the forces of attraction between gas particles are weak. Gases have no fixed shape, and as you increase temperature, pressure increases and particles gain kinetic energy and move faster. In a liquid, the arrangement of particles is regular and they are close together. Particles are moving, and they do move, but less slowly than in a liquid. In a solid, the arrangement is regular. Particles are close together, and in a solid, particles vibrate about in fixed positions. Very important point. Okay, now let me give you a difference between a chemical change and a physical change. A chemical change is one when new substances are made. So what we will say is the number of atoms on both sides of a reaction is the same, but atoms are arranged differently. In a physical change or physical state, then the change is that we go where there's a change in state. So when a solid becomes a liquid, then we will say that is melting. Melting is a physical change. We have gone from solid to liquid with no change in the arrangement of particles. And when a liquid becomes a gas, we will say this is boiling or evaporation. Melting and boiling both are physical changes. And when a liquid becomes a solid, we call that freezing. And a gas to liquid is condensation. Important changes for you to know. Right, couple of other definitions. What do we mean by melting point? And what do we mean by boiling point? Melting point is the point at which the solid becomes a liquid. So melting point is solid to liquid. Boiling point is when a liquid becomes a gas. If we were to plot a graph of temperature against time, then the graph is going to look like this. Now this point here, and let me change the color here, is your melting point, because the solid has become a liquid, and this point here is boiling point, because a liquid has become a gas. So that's basically the states of matter. The second thing I would like to talk about is mixtures. There's some key definitions here which I will say them. Now first of all, what do we mean by a pure substance in chemistry? A pure substance is a substance that has one or same type of atoms in the same proportion. Water is pure because it has 2 hydrogens and 1 oxygen. That's the arrangement of water. The water we drink is not pure because it contains minerals, fluorides, chlorine, etc. Gold is pure because gold only contains gold atoms. A mixture, now what's the difference between a mixture and a compound? Again, please check the definitions, like I said, from BBC Bite Size. A compound is basically a substance that consists of 2 or more atoms that are chemically joined together. 2 or more atoms chemically joined together, or I'll say chemically bonded, and we will look at this later on when we come to do the bonding topic. So the mixture is different substances, compounds, not chemically combined. Examples of mixtures. I'll give you 2 important examples: air and crude oil. Air is a mixture of oxygen, nitrogen and other gases. We can separate this mixture. Crude oil is a mixture of hydrocarbons of different carbon chain length. Now, a pure substance has what I call a definite melting point or boiling point. Water is pure because it boils at 100 degrees. Water is pure because it melts or freezes at 0 degrees. Give examples of few things. Argon has a melting point of minus 205 degrees Celsius, but lead to tin alloy will melt between 183 to 258 degrees Celsius. It's impure because it's melting over a range of temperature. Now that's 2 topics, ladies, done for yourself. Next time I will look at filtration and